I'm Karine van der Beek from the economics department, and very glad we got a part to present here what we do in our activity related to data science. Before I begin, I'm going to say two things, a little bit about the applied side in economics so that we can understand a little bit where data science meets us in the sense of how it's used and how and the things that are still challenging the profession when we come to use the new applications in data science, like machine learning and data mining. So, like any science, economics is about understanding the world, about finding regularities, and the way we do it is based on creating models or modeling the reality the way we see it based on different forces and basic principles in economics. And the next thing is relying on data, and you have this kind of negotiation between data and model. To understand empirical economics deeply is to understand that there are two things that matter to an economics or that guide an economist when it comes to his data. One is that he already has an hypothesis about the model and the reality that he should observe without looking at the data. And then when it comes to the data, what he will be worried about mostly is about the causal inference, that is about the causality between the result he sees and what he thinks is explaining it. So, in general, a big part and an increasing part of economics is empirical economics, and there is a growing interest in the relationship with data science. One of the things is that economists have moved to the use of very big databases. And so there's, given the new availability of large-scale administrative data, both in the private sector and the government sector, this creates new challenges, even sometimes just technical challenges, but also just in order to understand what we see, we need to employ many more tools and new tools. And well, just to see a little bit what it looks like. So this is the percentage of research published in the AER, the kind of #1 economic journal, the American Economic Review. So this is the percentage of papers that are empirical and that have been exempt from the regulation about data availability policy. That means that you have to give your data to be able, so that the people are able to replicate the data and all this. And these are the exemptions, which means that these are private data coming from companies or in different cases where you cannot show your data or you cannot apply with this regulation of the journal, and you can see how much it's increasing in the last decade. So, as I said, one of the things that worries an economist is really about the causal inference, and this is the primary focus of empirical economics literature. I mean, this is what we are concerned with, and this is what you will always hear, like the big debate will be whether you manage to identify the causal effect or not. There are other challenges, of course, and I'm going to mention them in a minute, but one of the things is that machine learning has already penetrated into empirical economics, and there is an enormous use of, first of all, of simple programming languages, like the use of R and Python, of course, and there's also lots of researchers using spatial programming in GIS, spatial programs. But then there's also machine learning and data mining, and there's many papers talking about it. So just recently, there's a paper by Susanetti from the Stanford Business School, who I will mention again later, but she kind of goes over the situation in this field. And she shows many examples where there is application of data science. The paper from 2015 argues that there is a set of problems where machine learning methods for predictions are the key part of important policy and decision problems. And then there's other examples where it's used to to identify kind of the optimal decision taking or policy making. And it's moving into more and more into the credit market analysis and into more and more fields in economics. But one thing we have to keep in mind, and here I will quote partly the things of Susanetti in the paper, where she says in the conclusion, at the same time, the automation of certain aspects of statistical logarithms does not change the need to worry about the things that economists have always worried about. A causal effect is a causal effect really identified from the data? Are all confounders measured? What are effective strategies for identifying causal effects? What considerations are important to incorporate in a particular applied setting? Defining outcome metrics that reflect overall objectives, constructing valid confidence intervals. And so she summarizes by saying, as machine learning automates some of the routine tasks of data analysis, it becomes all the more important for economists to maintain their expertise at the art of credible and impactful empirical work. So having all this said, I'll present the type of studies that empirical economists do in our department. I will start with Oren Regbi. Oren has a study where he looks at the effects of mandatory disclosure of supermarket prices. So one of the questions in economics would be whether transparency of prices will allow more competition between products, and what we should expect is to see a reduction in price. So there was a reform. So in this sense, to get the identification right and to identify the causal relationship, he uses a natural experiment. A natural experiment in this sense is a new policy from 2015 where Oren uses the situation before and after the policy, comparing in a technology or methodology called a diff-in-diff setting, where he uses a huge data set of prices of 10,000 products. So it's about 1,400, there's about 1,400 shops that have to publish daily the prices of 10,000 products. And so they use this change in policy to identify the effect of the transparency on the prices, because prices change anyway. So in this case, it would be very hard to find the causal effect of the change in prices. Another interesting study is by Shirley Lichtman with co-authors, where she looks at the trade-off between work and investment in higher educations, and she uses transportation and increasing the penetration of public transportation in the Arab sector. So again, the study aim is really to identify the effect of this penetration of transportation in the Arab villages, in the Arab towns, and see how it affected the investment in human capital and in labor labor market participation, given the changes in the relative costs of each one of them now. And so again, this is there's a certain strategy used here where you use the random changes in the transportation penetration, and using this exogenous treatment in a way, because of the fact that the transformation is randomly penetrating different villages at different times, you can identify the effect of these changes over the outcome you're interested in. And again, we're talking about merge. This is data from households, of thousands of observations of individual level data merged with data from the Ministry of Transportation. Another study is by Ada Gonzalez-Torres, who will be here later, a new faculty in our department, that looks at Africa and the effects of Ebola outbreaks. The Ebola in Africa, where was it? In Western Africa. And again, first of all, the database itself is interesting because it's self-collection of data merged with other types of data sets. And there's another, again, a kind of use of natural experiment within it. Ada is using many computer applications that not all economists are still are using yet at this stage, since many of them are quite recent, at least for economists, But apart from data that most of us use, she uses R and MATLAB and Python as well as QGIS and ArcGIS, and she also to extract the data, she also uses different systems that we know. But then in her study, she again tries to identify the causal relationship between conflict epidemics and institutions that evolve as a result of the epidemics and the disease. In my own research, which is about historical events, I look at the Industrial Revolution, and I try to make again a kind of causal inference to the past, looking at the geographical features and trying to find how they affected the type of economics or the sector which the area specialized in, and then the skills that evolved at the same area, and then given economies of scale and specialization, how this kind of created a path dependence of mechanization and the type of mechanization that was chosen up until the Industrial Revolution in the 18th century. For this data, we use a huge data set of almost like 450,000 observations, where every observation is a contract of an apprenticeship to an apprentice to a master in England. So it comes from different years and different locations in England. And we merge it again with geographical characteristics and other historical data sets that we have. And we use both visualization, given that it's a spatial analysis, we use GIS, but eventually it's a regression type analysis where we again have to struggle with the identification and the causality, but we use data for the estimation itself. And the last thing I'm going to present is a study by another new faculty that also works on Africa, that's Miri Strayan. And she uses another strategy that we use a lot in economics, and this is an experiment. It's really designing the experiment before the policy takes place. So she works in cooperation with BRAC, it's a microfinance project where, I don't know if you know this type of projects, is where they give very small loans to people in the village. And one of the ideas in this paper is to see how the relationship between the loan officers and how the effective portfolio rotation, like when they change the portfolio, how this affects the relationships between the staff, the borrowers, the behavior, the welfare. And so this is a field experiment, which is also a part of empirical economics and is used by at least 2 or 3 people in our department. Again, the data in this case will be self-constructed and matched sometimes with other characteristics from the area. And with this, I will end with research. Although we have more empirical researchers, I think half of our department is empirical researchers. Department of 26 or 7 people. So just a few words about teaching activities. So I'm not sure that the members of this department that we're cooperating with that are here are really aware, but we have both changes that we're making within the department, within in our programs, and changes that we're making in relationships with other departments, where the idea is to create the ideal economist who can both use his models, use his causal inference methodologies, but also use the new tools that are out there today and increase his efficiency of analysis. And so the first thing we did is to add to our program, to our BA program, a Python course that is bought from the computer science department. The Department of Industrial Engineering and Management has constructed, especially for us, a course called Data Science for Economists, where young economists can be acquainted with the basic methods of especially R, but also like R programming, but also methods of machine learning. And we have an R course for our graduates, which we also did as faculty members. The other thing is 2 BA programs. The second one I'll begin with is still awaiting university approval, and I hope we will be able to move things a little bit faster than they are moving at the moment. But the idea is to create, we already have a curriculum created by a team of members from the economics department and the computer science department. A very nice program that manages to put together all the million things that you need to study and to become both an economist and a data scientist. So this is still awaiting Duhugi approval, since the computer science department cannot have a Duhugi. And so this is hopefully going to be soon approved. The other thing we have is already running. We already have something like 15 students in it. And in a way, we're using an existing platform of Duhugi, of mutual. Sorry? I don't know, because it's not really double like in exact sciences. It's okay. Well.
2 degrees is the same.
Yeah, 2 things in 1 degree actually, but so it's not 2 degrees, it's 1 degree combined of both. So we just split the points into 2. And that's of economics with statistics, again with the Department of Industrial Engineering and Management. And this is a beautiful program attracting lots of students. And I think one of the nice things about it is that you do not become a programmer, but you do become a data analyst that understands things very deeply in terms of both statistics, economics, and the programs that are available to you. And so we only need to get some things straight at the university in order to increase this platform, but it's working very well with a lot of cooperation between the 2 departments. And that's it for now.